All right. So today we have Patrick Hadley from Snapchat with us, who's going to talk on the topic of Khronos body anchoring standards and glTF extension proposal. For folks who have been attending from the first session, like Patrick did have like a guest appearance in one of the session where he spoke in the water cooler. I don't know how many of you remember that, but yeah, Patrick, welcome to our EG, and we are looking forward to learning the contributions that you've been making with Khronos Group. And yeah, would love to hear your intro, and feel free to take over.
Great. Hey, everybody. My name is Patrick Hadley. I work in the product team here in Snap and their AR shopping technology team. I'm actually here representing Khronos. For those of you that don't know, Khronos is a standards organization board that one of the things that they've developed is the glTF format for 3D models, amongst other things. I work in the 3D commerce group. I also sometimes attend the 3D formats where the glTF is. And we have these different working groups. We call them, DTSGs. But yeah, they're basically working groups that kind of focus in on a certain area. And I've been leading or championing this, we'll just call it body anchoring DTSG. And it's looking at both avatars as well as 3D interactions with humanoids or, with the human body. Just a little bit of context why I kind of chose to lead this is because at Snapchat, we have a lot of virtual try-on experiences. You can try on glasses or shoes or apparel, clothing. And in order to kind of source models from a lot of different areas, we kind of need a consistent standard and spec to be able to place them consistently on, our target, which would be our Snapchatters or our humans that are using AR experiences. Therefore, when I heard about this, it originally was called skeletal, anchoring. It was definitely something that we were interested in, but the scope of it actually was larger. It was kind of, avatars as well. So we did kind of a short 10-week, 12-week kind of sprint to working group to get something that we can kind of share out by. We just had AWE, which was a conference that was in San Jose, Santa Clara area just this last week. And then also we would want to share out with some partners like you. So I'm going to kind of walk through a little bit of, the findings we had, what is the scope of the project, and what is the proposed output. Again, these are just proposals. Oops. And, this is where we're now getting feedback from different people and stakeholders such as yourselves. So what's the problem statement kind of overall? Right now, when it comes to defining, we'll call it skeletal anchoring, there's really no common approach. Everybody names things differently. There's different kind of points of interest. I like to point kind of in extremes, the simplest for defining an avatar, anchor points, I'll call them, is Mixamo. I saw only has 8 points, which is like on the knees and the arms, 1 in the crotch. There's like none in the spine or, none in the feet. And then you kind of get the other extreme, which is the Web3 consortium has over, 128 points kind of across the body here. So there seems to be a need in the industry to kind of have more standardization or kind of understanding of the points on an avatar. And this is where we also have the need to kind of define points for the 3D to human interaction. So with this, I'm going to skip down. The scope of the 3D commerce working group is we wanted to see if we could provide almost a standard naming convention for these avatars, look at kind of setting a parent-child hierarchy, but also kind of this could help map to other solutions that are out there. We'll take a look in just a second. And then what can happen with this base foundation is then people can build on top of it. So for example, if somebody wanted to have a virtual try-on that's not covered by an avatar, you can use this framework that we'd be, proposing or looking at, and then build on top of it. Just to make sure, it's more than just this list, but what's not yet in focus, stuff like the facial animations and blend shapes, that was, quite a bit there. So we kind of postponed that. Morphing 3D items, for clothing and accessories to fit all industry avatars. I know there's a Metaverse Standards Forum that's taking a look at that as well. and then defining the glTF's extensions for everybody. We would almost set this framework or proposal and then maybe build a couple glTF extensions on top of it that would allow, renderers or end clients and apps such as Snapchat to be able to kind of understand, hey, they're using this extension, we can take it in and place it, more accurately and have the placement kind of consistently and precisely every time. So jumping back up, here's an example of kind of what the framework we had envisioned. One would almost be we can use medical, but I would just use the term a precise location or placement. So how can you tell where on the body the specific point, would be? It seems like the medical is almost the most precise you can get. So that's where we kind of led for just using this example on the spine of, defining an avatar placement. And then there would be like a human readable, I call it a Khronos readable, that would be used more for the labeling so that the 3D artist doesn't have to go get a dictionary or the medical dictionary in order to understand. Like the vertebrae is pretty straightforward, but there's definitely some other points that are much more complicated. And then these would almost get mapped to other solutions out there. So as you can see, kind of just for this example, this is more illustrative that I tried to fill out. Even just starting with the root or the pelvic or the groin or the hips, like it's got different names across different ones. That tends to be the base of where an avatar kind of starts from, and then the parent-child spreads out from there. So just following from that center into almost like different points on the spine, we're not trying to define how many points an avatar should have. That's not the scope of this. We're not saying 2 is the right number or 5 is the right number. We're trying to provide a way to map precisely which point on the human body and then associate that with a common name that then could be mapped to however many points other people would choose. So for example, we were talking to the OpenXR standards. They're looking to choose 5 points kind of on the spine. If you look, I think Unity had like 2, and there was a reason they explained why they picked 2. I think there's some people from the VRM standard here. Looks like they have 3 with the spine, chest, and upper chest. So the idea would be not to define the right number because that's specific for a use case or an application, but to kind of make it so that there's more interoperability and consistent standard languages across them. And then we would, try to cover major parts such as the head, the arm, the fingers, the leg. But for example, nobody's really defined, if you look at the fingers, it's very well defined for a lot of systems because it's so important to when you have like a head mounted display and you're trying to, operate with your fingers and have different things. So having each one of these movement points tends to be very important. But nobody's defined something like the toes in that level of detail. So with this framework, somebody could go forward and kind of define that if there was a reason to. It's just we would start with kind of, what's out in the industry today, almost like a super kind of superset on top of all the stuff that's been worked. And then people have the ability to go in, make glTF extension proposals, and then continue to fill out the sheet for whatever that body part would matter the most for them. I'll pause here because the next things I want to go through is some of the virtual try-on things, but are there any questions? And I've got the meeting minutes up. I haven't seen any hands raised, but I'll just pause there to see if there's any comments or questions there, because I know there's a lot in those 4 slides that I presented.
Yeah, if you have questions, you can use the chat feature or the reaction. Yeah, so based on what Patrick presented, yeah, please.
And I'll pause at the end as well. So this isn't your only time to ask a question. Just want to make sure before I move on. Okay. If you do have a question, go ahead and throw it in the chat and we can, answer it as it comes. So with this, why is this valuable? So one will have kind of consistent naming or conventions. The reason I put a J there is because for some of the virtual try-on, there might be like an exterior or surface. I'm pointing to my head because we'll go into the eyewear as the first one, where it's different than kind of an internal, or I call it a joint. anchor point. So let's just take a look at the eyewear, for example. Right now, we receive models that are, glTF compliant that work pretty well, but if the placement is, on the bottom center of the model, it's tough to place that consistently well on the face, right? You might have different size glasses. We try to move transforms. A lot of what we did in the past is just let the brands move the item themselves, but that's not scalable. So what we wanted was to define kind of points that would be key points on the item, that if you had these 3 key points, anybody would be able to point, place this specific product, sunglasses or eyewear, prescription glasses, onto a human head that had the kind of the same points defined as well. So the points would be on the nose bridge, is the first point. That's kind of for the main placement. And then also the glasses angle would be kind of on the top of the ear. So with this table here, we would define, right now there's no avatars that have, I don't think, well, maybe there is, because if you look up on the web consortium, it does look like they have on the nose bridge potentially, but they don't have just the placement on the ear. They just have a general ear. So it'd be adding to that, specific to eyewear placement as a new extension. And it's not saying these are required. You don't have to go in and label your avatar with every single placement point here. It would just be for where your placement is, you can use the naming that would be used in this to kind of have more of a common standard name out in the industry. So we would define probably like a nose bridge, because this one would be on the surface. It would be something like an S or E for external underscore nose bridge. These would be on each point, the left and right of the top of the ear. So if we wanted to medically define that, or if we called it something else, that one column was more just to have kind of the most precise definition of where exactly it would be. The reason why this would be important is maybe for Snap, we also have earring try-ons that could go to, I think we have maybe 10 or so different placements where you can actually place an earring, like a 3D model, to see how it would look. There's the normal kind of just at where the stud is, but there's, many more that people get. There's even one that kind of goes across the ear. So the reason that you can't just have ear as your name is because there's different use cases need different points. And then this gives them the flexibility to define it and then have a common name that the industry could use. I've got 2 more examples and then I'll pause and see, if there's a discussion at the end. The next one we were looking at is footwear. As you see, we tried bringing in some shoes with the, generic occluder that was kind of being used. If they're all being made at the same time, it's a little easier to kind of make sure this doesn't happen. But when you're bringing in 3D models from externally and you need to fit them and place them right, and if the occluder leg, which is just, if you think when you're doing a virtual try-on with an AR experience, you don't want to see the back of the heel when your leg's over it. So it just kind of cuts, occludes the 3D model. This will allow having points kind of around the opening, as well as, down here on the bottom, the rear sole would allow for consistent placement, as well as telling if the opening tends to be where there's clipping that cuts in and the actual 3D model gets occluded in that opening if it's not big enough. So these would be placements that are interested. And then the next one we would look at is kind of around jewelry with ring and bracelets. So same idea. I'm not sure how much people on this call necessarily care about some of the virtual try-on stuff, but it's stuff that we deal with every week, if not every day, in accepting assets from external that we have to, modify or change or ask them to change in order to meet a certain spec or standard. So this would just be standardizing it for the industry to allow kind of more free interoperability. And then the added bonus is for any avatar, it's also the framework is more extensible to kind of help people understand, what an upper chest or a spine actually means, for example. So that's my presentation. I'll stop there and see if there's any comments, questions, concerns with the group.
Yeah, feel free to use the reaction feature or paste the question in chat. So one quick question that came to my mind was, but first of all, great presentation, Patrick, good job on aggregating all the backbone definitions across different standards.
Thank you.
And one thing I was curious was this specific standardization effort would allow you to, like, let's say, for example, the examples that you gave, like the glass, knowing those attachment points will allow you to use the same glass across different avatars. How do you decide, like, for example, imagine a child having a smaller head and an adult having a larger head. Both of them will have the same socket points. How do you differentiate which one it will fit better?
Yeah, so there's two different kind of approaches with, for example, eyewear try-on, and we have this available on Snap today. One is just general try-on, and then one is true to size try-on. And the important distinction is for general size, we'll actually change the 3D model to fit the head, right? Like it'll kind of expand out so that it fits the head. So we have a start with an occluder head that's maybe a generic size. And if somebody has a big head or a small head, like let's just use a child, for example, we'll actually, change the model as the occluder kind of fits the best fit of that target. We'll actually move the model or scale it to fit that. That's different than a true to size try-on experience. And if you think about it, if the head shrinks significantly and we are placing it from a known distance, let's say the center of the head, your glasses are now going to be up here for that child, right? So it's not going to fit. But with this, you get one, more accurate placement, and two, you can do the true to size and you just see it's too big for you, right? Like if you wanted to place it, because you're placing it based off of the nose bridge, not based off of like a head quadrant or something that's more on the occluder. So it does work for, this approach still works for children. If you wanted to have glasses for children, you just kind of resize your occluder head. That's kind of what the 3D model is, fixed off of. And then you can scale the 3D model off of it, or you can choose not to scale it and have a true to size. If there's like a LiDAR for AR, for example, if there's a LiDAR camera, you can fix the size because the accurate dimensions. So I think the same thing would apply for an avatar as well. If you have dimensional information, if you're trying to place it off of some other point, you're going to have that positioning, kind of like what I'm showing on the screen, errors. But if it's positioned right here on the nose bridge, it'll always be in, like, as people are talking and moving, this is the place that kind of moves the least when you're, doing facial animations and stuff as well. So it kind of has that consistent placement, as well as, with the ability to kind of keep true to size or modify as needed.
Interesting. Yeah, thank you for that information. And just to clarify, when you say true to size, it means you have an authored asset for that size. In the case of like scale, you just scale it runtime, I believe.
Well, when they make the 3D model, usually they'll make them to a certain dimension, right? So shoes, we try to fit it to like a size 9 because it's not actually true to size. We'll just scale it to your foot. But for something like glasses, we actually would, build it to the dimension, or whoever would have the 3D models could build it to the specific dimensions. Think of like furniture. They'll build furniture models to the specific dimension. And when you put it into like a surface placement, like a flat horizontal surface, it'll come true to size. Like it's not, you have to scale it and do that. Same thing with glasses. When they build the model, they'll build it to the actual size as long as they have that, like on a detail page, or, they get that information. So that's what they'll build to. It's just when they kind of fit it onto the occluder, maybe they'll do some adjustments there. But if we want it to be a true to size, then we kind of keep it as that base 3D model, and we don't really scale it or stretch it or scale the 3D model at all. So the 3D model has the ground truth, or is supposed to be built as what the size of those glasses would be.
Got it. Yeah, thank you for the information. Anyone else have any questions?
I have questions. This is Neil from the forum in Khronos. Hey, Patrick, that was a good presentation. Thank you.
Hey, Neil.
I know we were kind of chatting. I mean, do you think there's a chance that the 3D Commerce Group will want to define this kind of common naming spec, or
let me ask. So My interest is more on these virtual try-on sites and naming something like the nose bridge, having a common name, something like the ear here. That'll help the industry for commerce very tremendously because, we've kind of focused on the 3D model in isolation and kind of defining all that, but we haven't really done that human to 3D interaction. There was a comment that we had just we went to the AWE, we had a face-to-face group with Khronos, and somebody had brought up the fact that sometimes when you're rigging an avatar, it's not always specific to a point. So like, let's just use the shoulder, for example. It's not always going to be exactly where your shoulder is. Sometimes they might move it somewhere for kind of motion, which that was news to me. Like, I'm not an expert. I'll be, the first to admit, in avatars. I did a lot of desk research to understand like kind of, the different formats that are out there. I think somebody from VRM is in the team. So I looked at VRM. I know that's kind of the one that's gotten the most consistent traction of being the solution that people, go to that's interoperable in different places. But I would be curious from this group, any thoughts on more on the like rigging and skinning side of the avatar, if you think that this kind of approach almost at the medical term, or if there would even be a way to define, and somebody was using the example, you might have it at the elbow, but you might have a few other points down the arm for the twisting and like the rotation. So again, this is a newer area for me, so it's more for my education. I'm wondering if anybody has any kind of thoughts on seeing this framework and has worked with avatars pretty closely. If you have any opinions on, the precise term, if there's going to be any challenges there. And it's really about the anchor points. It's not so much how it's going to move or the rotation or any of that. I think you can do muscles and different stuff there. It would just be kind of on the naming of the anchor points.
Right. Yeah. Just one thing. Yeah. Like, I think on that note, I was looking at your slide 12, where you have this standard names, right? So all these refers to bone names, right?
Yeah. And what's interesting is like, if you look at the VRM standard, they'll use the bone name, but it's like, it could be like upper arm or lower arm. But that's the difference between like shoulder and elbow. So it would be something similar where if we use like elbow, it kind of defines that anchor point that's kind of talking to the next, extension of it, which would be the upper or lower arm. But yeah.
Perfect. Yeah. So yeah, one thing that I've seen in game engines, like in fact, I think it was at a high level covered in the session 2 of our meeting, is a concept called sockets. And it's that specific terminology is used in Unreal Engine. And what it allows is it allows you to define these attachment points as per the need of that specific avatar's character. So this will be like an offset from a bone point. And
yeah,
that could be used like in a game, like, to position a gun where, like, when you're trying to place a gun, it's probably like not on the bone, but like with an offset. So it allows you to add more authoring points. Is that something that you guys are evaluating as well, in addition to the bone names?
Yeah, and I think, so this is where it depends how they do that offset. So if you just use the hand, there might be a hand, but it might also be the like wrist. So this is where it kind of gets a little tricky, is like somebody might call it hand and it might actually be the wrist because that's talking about some of the parts of the hand or the bone structure that goes from there. And some people might have a hand that's like actually somewhere in the hands. But in theory, the idea is if you can define it in your avatar, it should almost kind of map or correlate to something that's more medical or kind of more precise defined. And then we would have a name that would be used for that location that then other people could say, oh, they're talking about this position within it. And then if they wanted to do an offset of like, 2 inches off of that to place the gun, that would be completely fine too. It seems like it's very much almost like a virtual try-on like definition, where they just need to define a point of interest, let's just call it a like, hand grab or something. And then it's always, I don't know if it's different for like a gun versus a sword versus a whatever else it would be, but it'd almost be a new point and then come out with this precise kind of term. There'd be a human readable name, and then they can add offsets to either side of it if they wanted to. So I definitely think that would work here. And then the idea is that this is more of a framework that somebody can kind of build off of and propose that as an extension for Khronos to kind of have the consistent naming and the definition of where it is, that then can be used interoperably. You know, if you have a Unity game versus, you know, Unreal, or like different, let's even use Roblox, might be more of a challenge because they're not as humanoid as the rest, but it could be kind of used consistently across as like the standard. But part of these glTF standards is you have to get industry feedback. You can't just propose your own thing and then not get any feedback. You have to kind of make sure that everybody is aligned.
Got it.
Yeah, there are
Chat, yeah.
Yeah, there's a question coming in. Is it possible to allow the end user to move another angle, to move the head 45 degrees? Yes. So what happens if you almost envision, let me hold my phone. The glasses are almost just like, you know, a 3D item. And then as the user moves that head, we have kind of a 3D, like, you know, mapping of the user through ML and machine learning. And as the user moves their head, the 3D object will move with their head. So it's like anchored or positioned somewhere. And then we've got ML to kind of identify the human form. And then as the user moves their head, we have kind of a 3D version of the head that moves with it. And then in the screen, it's kind of following where the user goes. And that's what the importance of the occluder head is you don't want to see the back of the glasses when you turn your head sideways. You want it to kind of cut off like a real, you know, glasses would, how it would be looked, right? So if you could see the back of the glasses through the head, it would break the experience. So that's why those occluder heads serve two purposes. One is to kind of, you know, shape to the target, and then the other is to cut out the back of, you know, something that shouldn't be shown in a virtual try-on experience. So let me know, Elliot from Tavar, if that answered your question, but I'll jump over to Ruslan's question. Is there a universal avatar skeleton? Great question. Originally, we were kind of coming in skeptical that we would try to define a universal skeleton. And I think through our desk research and through, you know, understanding the industry, I think the answer is there probably won't be and there shouldn't be. And let me explain my thoughts why, but I would love to kind of have a discussion with you guys. So yeah, we didn't see a universal avatar skeleton, either in naming or in the points that, you know, matter. Probably the closest one would be something like this Web3D that kind of tried to use medical names, but it was interesting how they picked some of the stuff. I'm not exactly sure how they picked some of the stuff, but yeah, the short answer is no. There's no universal skeleton. There tends to be a T pose that all of the avatars tend to, you know, get into in order to do the rigging and the skinning. So you have to put your avatar in a certain pose, and then you point these points of interest that are unique to each solution. So Mixamo was shown, VRM has their own, ARKit has their own, something like Ready Player Me has their own, or Real Human. So each one has its own solution. And the idea is not to say XYZ solution is the one that everybody must now conform to. It's more to kind of help the industry understand what each of those points are. So if I say upper chest, you get a better idea of what an upper chest for VRM, you know, position would be and how it might relate to other solutions. I'm not sure. I know you guys have, is it Hikito from VRM? It would be, I'm probably saying your name wrong, but Hideki.
Hi.
It would be, yeah, it would be interesting to kind of hear any thoughts that you have, because I know VRM is kind of the one that I consistently hear is what people go to because your interoperability. And I think I attended one session where maybe you presented and you were saying that you guys build kind of the interoperability with Unity and with Unreal and some of these engines. So it does that. So I'm just wondering how challenging that is, and the naming, you know, if you guys are able to kind of see which points go to which in different areas there. But yeah, anything you have to add, I'd love to hear your perspective.
Yeah, thanks for asking. So like VRM is actually based on the human IK, which is, I think it was proposed by Autodesk, I think. I think it was it's using the Maya, and we conformed to that standard. So what I think, what we think is that, and I think human IK is also used on the Mixamo as well. So yeah, I think we should, we should lean towards that. Would be a good idea. And yeah, and the point you mentioned about the attachment point, yeah, we are thinking that those ideas are also interesting as well, and we might include it in the future updates. So yeah, I think we have a common interest there as well.
Because what was okay, yeah, I would love to, spend as much time. I know you guys are time limited, so I'm gonna check, with Zeno and kind of see, but we can always set up further discussions. But like, for example, Mixamo doesn't even have a spine. I use the spine because it's one of the most clear ones that kind of help you determine where on the torso something like an upper chest would be, but I don't even know if you guys are using spine or kind of using points, further out. I do have, links to the VRM standard, but my concern is if we wanted to do something like the ear, let's just use it for our example would be piercings of the ear. I don't know if that standard you referenced, the humanoid reference was, that detailed. So we wanted to kind of do more of a superset that includes stuff like that. So it'd be that plus is what we'd be looking to kind of define. So maybe I can, my email will be there with this. I try to attend this every once in a while, but I've got a couple other Khronos meetings, so I can't attend every week. Just, a lot to handle. But yeah, maybe we can set up kind of a dedicated deep dive for anybody that's interested, because I know we're probably running close to time right now for this discussion.
Awesome. Yeah, thank you, Patrick. And yeah, feel free to share your email or the best way to contact you in the chat if folks needs to reach out to you. And yeah, in addition, based on the previous discussion, like last week we had a speaker, Quentin Averill from Interdigital. So one of the things they mentioned was that they are working on standardizing more detailed avatar. So probably might worth evaluating their standards as well. And that session is recorded, so you will also find it in the Metaverse Standards Forum portal. So yeah, so that's the update. And